Today we're going to talk about another method of solving quadratic equations. This method is called completing the square. In this method, we're going to add a constant so that we create a perfect square trinomial. Remember when we worked on perfect square trinomials back in Chapter 7, an example of a perfect square trinomial might look something like x squared plus 8x plus 16, which once we factor it, we'll notice that we're going to get x plus 4 times x plus 4, or x plus 4 squared. So how do we complete the square? Well, remember that standard form is ax squared plus bx plus c. So our first step is to find half of the b term, the coefficient that goes with the x. Second, what we're going to do is square the result that we got from step B. Then what we're going to do is add that result from step 2 to the x squared plus bx. So it doesn't really make a whole lot of sense right now until we can see it in some context, so let's look at example 1. So example 1 is asking us to complete the square for each expression, then to factor the trinomial. So we'll notice x squared plus 6x is not even a trinomial yet. What we're going to do is learn what to add to it to make it a perfect square trinomial. So step 1 says to take the b term and cut it in half, or multiply it by 2. Our b term is the 6 in front of the x. So step 1 is going to give us a 3. Step 2 says take that answer and square it. So we take the 3 and we square it to get a 9. Step 3 says now add that to x squared plus bx. So we take our x squared plus 6x from what we started with, and what we're basically going to do now is add the 9 to the end of it. And what that has created is a perfect square trinomial right here. And then to factor this, we know the perfect square trinomial, it is x squared plus 6x plus 9, is the same thing as x plus 3 squared. For second one, we can look at the same idea. We have x squared minus 9x. So again, step 1 is going to tell me to take 1/2 of my b value, which is now negative 9, which is going to give me negative 9 halves. I'm just going to leave it as negative 9 halves for now. Then I look at step 2, which says to take that from step 1 and square it. And that's going to give me 81 fourths. Step 3 says now I'm going to add that to my existing expression, and what that is going to give me now is a perfect square trinomial. And when I factor this, we're going to get x plus, take that back, it's not plus, it is x minus 9 halves squared. And again, if you wanted to FOIL that out, you could see how that is going to FOIL back out. So that skill is kind of a good thing to know how to do, but really this is where we want to start using it when we're trying to solve equations by completing the square. So here's how we're going to do this one. So if you'll notice, way back up towards the top, we were looking at this x squared plus bx was what we were trying to add to it to make the perfect square trinomial. So keep that in mind down here for this equation. So for this equation, what we want to do is we want to actually isolate the x squared plus 8x by itself. We have been doing an awful lot of bringing the 17 over and creating a 0, but that's going to make a trinomial. To do the completing the square, we want to have x squared plus 8x, and then focus on what is the number that's going to go to it to help complete the square, and then continue to solve. So what we're going to do is we are actually going to move the 3 to the other side by adding 3 to isolate the ax squared plus bx on the one side. So this is now where we're going to focus on the rest of this equation. Okay, so to complete the square on the left-hand side, that very first step we talked about is to take 1/2 of the 8, which is the b, which is a 4. Step 2 says square the 4 to get us 16. Step 3 says add it to what we already have. Now this is where we have to be careful. Adding it to what we have. So we are going to add the 16 to the x squared plus 8x plus 16. However, remember, we are dealing with an equation now. And in that equation, we had a 20 on the right-hand side, and we also need to make sure that we add 16 to both sides. Remember, we can't do something to one side and not the other. This is an important step to make sure, whereas the first example up at the top with a and b, we just added a number on and we didn't think about anything else because we were dealing with an expression. This is now an equation, so both 16s have to go to both sides. Okay? So from here, we can now continue to go. So this is going to give me x squared plus 8x plus 16 equals 20 plus the 16 is 36. And then what I want to do is look at this perfect square trinomial right here. Okay? That is going to become x plus 4 squared equals 36. Okay, so again, notice that I didn't bring the 36 back across. We've created this perfect square trinomial, so I want to use it. Now at this point, because I see x plus 4 squared, what I can do is I can undo the square to help me get inside of what I'm looking for, which is the x plus 4. So by taking the square root of both sides, I now am left with x plus 4 equals the square root of 36. Now remember, the square root of 36 is both plus and minus 6. And I need to make sure I include both of those. Once I have this plus or minus square root of 6, I then look at x plus 4 equals 6, x plus 4 equals negative 6, and I solve by subtracting 4's. X equals 2, x equals negative 10. So my solutions are negative 10, comma 2. Okay, so again, we're finding answers to this quadratic without doing graphing, which is a good thing, but we have to make sure we can work through our algebraic steps. In this next example, we're going to look at how we can use completing the square to solve a real-life application. What we can see from the girl that's standing on the edge of the cliff is that she is throwing a stone up with an upward velocity, and I think I want you to notice the upward velocity piece of a 32 feet per second is here for the b with the bx part of the term. We know that she's throwing it from a height of 16 feet, which basically means our initial height is our y-intercept, or our 16 at the end. The negative 16 is accounting for the gravity pull coming back to Earth. So what we want to know is, when does the stone land in the water? In the water, or landing in the water, would tell us that we wanted h to be 0. So our first thing is going to be to look at our equation with h plugged in. So negative 16 t squared plus 32 t plus 16 equals 0. Okay? We know that our very first thing that we should look at for all of these is to take out our GCF. If I take the GCF out, I get negative 16 as a common factor to all of these. That will give me t squared minus 2t minus 1 equaling 0. I would then think to divide both sides by negative 16, which is basically going to kind of just cancel them out on both sides. And I'm left with t squared minus 2t minus 1 equals 0. The problem we have here is this is not factorable. Okay, so because it's not factorable, what we're going to do is we're going to complete the square. We're going to use one of these other methods, completing the square. Okay, so when we complete the square, what we know is t squared equals 2t minus 1 equals the 0. We need this piece, ax squared plus bx, to be isolated. So to do that, our very first move is to say, well, let's move this 1 over to the other side. And again, we're doing that because we need to find a way to create a perfect square trinomial on the left-hand side to be able to work with. Okay, so from this point, we are now going to use our steps. So first step, 1/2 of the b value, -2, which makes a -1. We then take the -1, we square it to get a +1. And then we take that and add it to what we already had. So what we already had was t squared minus 2t plus 1. And then on the other side, we already had a 1, and we need to remember to add it again to both sides. So that's going to give us the equation here of t squared minus 2t plus 1 equals 2. This is what we are now going to kind of work on. So then we come over to here. T squared minus 2t plus 1, again, is our perfect square trinomial, which really becomes t minus 1 squared. And on the other side we have 2's. At this point, I can now take the square root of both sides, which is going to leave me with t minus 1 equals the plus or minus square root of 2. From here, because again we need the plus or minus, what I need to consider is t minus 1 equaling the square root of 2 and t minus 1 equaling the negative square root of 2. Okay? So from here I would be adding 1 to both sides on both equations, and when I use my calculator here, I'm going to end up with t is about 2.4 and t is about negative 0.4. Well, we know that we can't have our time landing in the water negative 0.4 seconds. So because of that, we are not going to consider that answer there. What we are going to consider is just moving up along here a little bit further, and we're going to say that 2.4 seconds it will land in the water. So completing the square is not an easy one. It definitely will take some practice. It definitely takes some understanding of the steps. It is something that can be very helpful, especially as you get better at it and you can see how it works. It will definitely be a good tool to have as another method to solving these quadratics. So it's definitely something we want to practice, we want to work at, we want to understand, and try some. Let me know if you have any questions, and we will move on from there.